Hey guys, I want to thank you for joining today's toolbox talk. We're going to dive into a couple diagnostic steps, procedures for Whirlpool electric range. When I say walk through, I probably more or less mean stumble. I haven't exactly done this with the GoPro before, so bear with me as I learn with you guys. We'll take it from there. I think we're going to start with diagnosing bake and broil elements, then we'll kind of move up to issues that we bump into with the burners, their terminal blocks beneath there. We'll move up to the infinity switches and control boards. Touch on some basic PPE, any safety procedures we can along the way. Feel free to dump questions in the chat, and I might take a couple opportunities to pause. Nonetheless, let's dive in. I've started by disconnecting the powered appliance, turning off the power at the breaker, step one. I'm going to hog this appliance out now. We'll kind of tear down the back and then start troubleshooting from there. Hang tight, we'll get started. First thing we're going to do is test the bake element down on the bottom inside the appliance. So everyone did get some of those Milwaukee toolkits distributed. It's one of our big new hire incentives. They're a great thing. I am a Fieldpiece guy. I've had this one for years and just haven't been able to spend the money to upgrade, so bear with me. I'll do my best to make this hopefully translatable for those Milwaukee devices for the purposes of this demonstration. All the functions are pretty much spot on the same. A quick note here, something that would make access easier if you don't have long arms. If you flip these cam arms out like that, you can remove the face of this door. Just like that. That way you can set it off the side to work in there. Just access. Fun tip for you guys. Reinstallation or installation of a replacement door would be the exact opposite. Reset your cam arm. Give it a few tests. Make sure it's in place. Two screws, that's it. Two screws. So we can revisit things since we're at this point. What we have done up to here is hog the appliance out, removed the trays, the bottom tray to make that a little bit easier. We've turned off the breaker outside, verified power is off to appliance. And now we're going to remove carefully the bake element with two spade terminals on the back end. Alright, advice here, pro tip. Bend these to the side and out of the way. Do not let them pull back into this insulated mess. You will save yourself a lot of work. What I've done is isolated the bake element. It's just a large resistor. Gets nice and hot. But we can test it just like any other part of the circuit relatively easily. I oftentimes use the term ohm it out. And probably what I actually mean is check for continuity. So if you guys hear me say ohm it out, bear with me, roll with me. What we're doing is just making sure that there's a complete circuit from one end to the other. And I suppose if we were to ohm it out, I don't know, should we get somewhere between like, yeah, probably between 10 and 40 ohms is normal for a bake element. I bet your broil element's probably a little steeper. Of course, we've just confirmed that the bake element is in fact intact. Oftentimes what you'll see, like the complaint I get oftentimes is that they had a huge flash, heard a pop before the oven stopped heating. You can usually see signs of visible damage on this. I believe it's a nickel alloy that they use to insulate your bake elements. So delicately, we're going to flip this around and reinstall the bake element. This procedure is identical for the broil element. You'll see your pair of screws here. This will hog out. Make sure you do not lose your wires to the back end. And reinstallation is very similar too. So hang tight. We will get this all reinstalled, put back together, move on to the next diagnostic step. The most common issue I see with our burners, our stove burners, the burner's inoperable. It's oftentimes these terminal blocks underneath. Just like we did with the bake element, we're going to quickly check for continuity on what I would call the stove burner itself. So on my Fieldpiece, you flip the dial to continuity. It looks like that little triangle with the stop after it, the second one down there. So MFD is microfarads, which would check for capacitance. Continuity, that function is scan, and then ohms is the last one. That indicates to me that there is continuity between this burner. If we change it over to ohms, like I said, I often mix these two up. Ohm it out. Passes no ohm test as well. So we just verified a good stove burner. And when I'm talking about the terminal blocks is this guy right underneath here. These two, not necessarily spades, but they sit back into this terminal block, and this is where the actual power comes from your infinity switch and the control board. Again, this complaint often comes with a trip breaker, an arc flash, and then suddenly the burner is inoperable. I like to visually inspect these. They tell you a lot without having to plug into them. It's just plastic. They overheat, melt. Things oftentimes boil over. We're all human. And it's truly it's a relatively inexpensive fix. You'll get the replacement terminal block. I like to go with an OE specific, a Whirlpool direct replacement. That case, you'll get terminal block with probably a 1.5 feet of lead on either end. That way you can reassemble your terminal block, plug it in, and you get ceramic wire nuts that come with the kit. So you can putting them back in the insulated cabinet here in a nice, safe, snug spot. Okay. Hey, from here we can identify our infinity switches, our control board. These are spendier components, but I really see these fail just as much as, more often than a bake element, just as much as a terminal block, especially the infinity switches. So, with our meter, and with some guidance from a wiring diagram, that would be nice. But we're going to figure out who's what. I was just popping this panel off and stumbled across this little mouse here. So we'll get that junked out and then we'll continue with our little diagnostic steps. How's that sound? I wasn't a big fan of guessing. So in digging for the wiring diagram, we ended up digging it up somewhere inside the back cabinet here. Wiring diagrams do scare everyone, but they're not terribly difficult to interpret. Just take a little bit of time to doing so may help you out quite a bit understanding how to test these things appropriately. To some extent, think power in, power out, but then you have this one supporting terminal that has 3 wires coming into it. These come in handy for just telling us who's what and what power comes from when to where. These diagrams are very specific. Let's track something down. Main oven temp sensor. So it's a violet wire, VT. P3 5 and P3 4. Do we have any violet wires? These look violet to me. If I can get my head underneath here to peek at the indicator, I do have P3. Position from right to left is going to be these 2 yellow wires. 1, 2, 3, 4, 5. So this is going to be P3 4 and this will be P3 5. Don't even know what that does, but we're just tracing wires here to find out what it is. Let's see what this one. This one's P2, P2 1, 2, 3, 4, 5, 6. P2 1, P2 6. P2 1. It's going to be our white wire. P26 is going to be our black wire supplying our oven light. This is our oven light. Simple as that, following the steps. This is going to be power coming into the bake element. This is the bake element circuit. Similarly, this is going to be your power coming into your broil element. This will be your broil element circuit. Your broil element, as indicated by the wiring diagram, has a thermal fuse. So if it gets too hot, it will pop. Those thermal fuses are a one-time. If they break, they're done. The same thing, you ohm them out, you check for continuity, isolate it, just like we did the bake element. If you don't have continuity from one side to the other, then it's blown. If you do, the fuse is still operable. And the issue, if you're having an issue with the broil element, is going to be likely in here, in the control board. You can always look for signs of swelling or popping on any of the capacitors. They're built into the board. I don't have recommendations for soldering or anything, but these boards are 150, 200 bucks at Sunberg, so they are simple, easy to pop out and replace. This would be for the keypad adjustment, the board itself. All of these harnesses unplug, this ribbon unplugs, carefully remove and reinstall. There's going to be a core charge on most of these control boards for the precious metals, so do preserve it, return it to Sunberg so you get the credit. These infinite switches, let's pull out our multimedia here and go through diagnosing. Well, let's figure out what everything is first. If we look at our wiring diagram, for our cooktop infinite switches, and the one I'm messing with right now, these are brown wires. Let's see, this is to my terminal blocks, to be clear. So this front one, I've got orange, this one has brown, I've got blue back here and yellow back here. So I'm looking for the small left front burner, which is going to be brown wire application. Looks like it's right here. So my L1 is going to be my black. My red looks like it eventually turns into my L2. So my H1 and my H2 are going to be my actual brown wires. These are going to go to my burner, my stove burner. Test here. Maybe I should have said omen out, right? Because that's going to tell us more than the continuity test will. Yeah, 37 ohms. Using the rest of this wiring diagram as a reference, it's going to tell your nominal resistance or voltages. So your broil element, 10 to 40 ohms is normal. Bake element, 10 to 40 ohms is normal. Yep, refer to any of these for troubleshooting. They are so helpful for model-specific information. We're going to test our line 1 and line 2 for continuity between our H1 and our H2, our heating coil leads. Okay, so the switch is in the off position right now. I don't think there's going to be, so this is our L1. There should be no continuity between anybody. Let's make sure we're on continuity. No continuity between anybody. Okay, so let's flip the infinity switch on. From L1 to H1, nothing. From L1 to H2. So it looks like that circuit is closed. From L2 to H2, this must be H1 or something. And there's our H2 to H2. And so the idea with an infinite switch is that there's not just a high, medium, low setting that you can really dial in the, I don't know, 1 through high, low through high. But we just confirmed that this particular appliance here is good. It just passed our test. With the switch on, checking for continuity, here, which would be across H1 and H2, we should have no continuity. If we were to have continuity or to have a resistance across these two, would indicate that the switch had in fact shorted. Additionally, you will, when we tested for continuity, we confirmed continuity between L1 and H1 and L2 and H2. Another symptom of a faulty infinite switch is that you lose continuity. Something breaks internally that prevents those from communicating. We're going to look at the actual outlet now. 3-prong 240-volt appliance. So, just as we did with the bake element, the controls up here, checking for continuity. If we were to pop this lead, we could ohm from each one of these leads to their location on the appliance. So if we think that maybe there's a bad power cord, there's a kink in the power cord, this is a quick way of ruling that out. See that there? That's a good sign. So actually testing the receptacle, this is a fun one, because sometimes you get a bad neutral or a bad breaker. I also like to calibrate my multimeter every once in a while, and shoving this into a live outlet is the best way to check and make sure it's reading appropriately. When my battery gets low, it reads all sorts of goofy, crazy things. So again, we're now just testing a live outlet. PPE has to be in place. Gloves, glasses, and insulated test probes. So right now I'm testing across. So each one of these legs, my red and black, is going to carry 120 volts. So from my neutral to one leg, I'm going to have 120. From the other leg to my neutral, I'll have 120. From one 120 leg to the other 120 leg, that's how you get your 240. So, what you're going to find is when you have a bad neutral bar, bad neutral on, happens a lot with the AFCI, GFCI combination breakers, the breaker is feeding back through the neutral line of this dedicated outlet. So maybe the oven is heating on while no controls are on. So you can easily check this by running your neutral to any ground. There's probably an outlet behind this microwave. You could shove it right into that ground if you were checking this neutral. But again, across you should have 240. The other symptom often is if the bake element and the broil element aren't working, but the timers, the cooktop work just fine. It could be there could be one bad leg to the breaker. So you're going to get 120 volts across because you've dropped one leg. Guys, I hope this was helpful. I'm going to get some of this back together and open it up for questions.